Ready whenever.
Hey guys, this is Nick Miller, Wild Christmas Lights, and I want to go over the power rules and using connectors and running power wire from the outlet up to the roof where the lights are, or to your mini lights, whatever you're going to use it for. So first, the power rules. So there's going to be different rules for incandescent lights versus LED lights, because a LED bulb right here, this is 1.2 watts. There's some that vary. Some LED lights are 0.8 watts, but let's just be more conservative and assume that it's a 1.2 watt LED bulb, C9. And then this is a 7 watt incandescent C9 light. So this uses a lot more power than this one. So how do we get our numbers? So internally, we do not want to put more than 135 incandescent bulbs on one SBT2 wire. So SBT2 is 10 amps, and it'll carry more load than, I don't know if you can see the difference, but this is SBT1 wire, so it's thinner. It has less insulation, and this will carry 7 amps. Or actually, it might be 8 amps. But our rules internally for incandescent is that we have 135 C9 before we have to run a new power to it. And so the way you get the math is you have 10 amps, and 1 amp in the realm of 120 volt power, so let's assume that's a constant. 1 amp equals 120 watts. And so 10 amps is 1200 watts. And then you take a incandescent 7 watt bulb, one bulb, 7 watts. So, drum roll, 1200 watts divided by 7 watts is 171 bulbs on one run, and that would fully utilize 10 amps. But the problem is, sometimes you run these a long ways, and there's some resistance, and they overheat. And we've had a lot of timers and other things melt and, try to catch fire. So as a company, we decided that we're going to stick to 135. We want to be really conservative. And so we use, for incandescent lights, we use a 10 amp wire, and we never exceed 135 bulbs. And we have a safeguard in place in that every power wire that goes to the house has a little tag, and the installer, the crew leader, writes their name and how many bulbs are on that power wire, just as a double check to make sure no one exceeds 135. Otherwise, that crew leader gets a $100 fine. So when we move to the world of LED, our policy is 300 LED C9 bulbs per one. I think SBT1 is 7 amp. Let's assume it is. And so this number is really conservative. I feel like it just gets really long, and the longer you get your wire, there's some resistance that happens, and it has more of potential to overheat. So when we do the math, and so an LED C9 is 1.2 watts, as we mentioned. So when we have 7 amps, that means that that wire could hold 840 watts. And then when we take one LED bulb, that's 1.2 watts. And when we divide 840 by 1.2, that means, in theory, we could put on 700 bulbs on that one run. But that's crazy. So, a 700-foot wire, I just feel like that would be inviting problems. So there might be somebody out there smarter than me that would say, yeah, just do it, it's fine. But we're trying to be more conservative. We installed 1,365 houses last year, and we want the statistics to be on our side. So we're going to always take the more conservative approach. So these are the rules for how many bulbs could go on one power wire before we have to run a separate power wire. Like, let's say a roof has 240 incandescent bulbs on it. Well, you need to have 2 power wires going from the outlet up to the roof, to split it. So one power wire never exceeds 135 incandescent bulbs. So these are the rules for just the power wire. But there's another dimension that you have to take in consideration, and that's over here. So how many watts or how many bulbs can you plug into one outlet? So, you know, by adding like a 3-way, you could plug 6, 7, 8, 10 wires into one outlet if you really wanted to do that. But at some point, you're going to trip the breaker, and the client's going to be really mad at us because their lights never work. So our rule is we're assuming most outdoor outlets have 20 amps. Okay, that's standard. It's not going to be more. It might be a 30 amp. That's really rare, and the plug will look different. But let's assume it's 20 amps. And so we need a margin of safety because sometimes that outlet is also attached to an inside light or the lighting for the kitchen. And if you run 19 amps worth of Christmas lights to that outlet, what will happen is they'll have this big Christmas party, and then they use all of their electricity, all the lights are on, and it trips their breaker, and they're really pissed. So margin of safety, never exceed 15 amps to that outlet. And if you are going to exceed it anyway, so let's say that you have 20 amps of lights that you have to plug in, well, you know you're going to have to use 2 separate circuits. So even those out. So don't put 15 on one and 5 on the other if you could help it. Do 10 and 10. That way the lower amount of amperage that you're drawing from each circuit means a safer display and a lower chance that there's going to be issues. So if you have incandescent bulbs, then no more than 257 incandescent bulbs should get plugged into any one circuit. If you're using LED, no more than 1,500 LED bulbs into one circuit. That sounds crazy. So this is based on the math, but I would say, 800, 900. I mean, come on, move it to another circuit. So, and if you don't know how to figure out what circuits are attached, so you might have an outlet on one side of the house and then an outlet in the eaves or something. Outdoor outlets normally have a little trip button, and so you could test get a little tester light and do the manual trip so that that GFI gets tripped. And so you could go to that other outlet, and if that other outlet still has power, that means it's on a separate circuit. So bada bing, you're in business. So you could also ask the homeowner. There's some other tips and tricks for ensuring that you're utilizing separate circuits. So enough of the power rules. So there's 2 dimensions. You could have a certain number of bulbs go to an outlet, which is higher, and then you have a certain number of bulbs that could go onto one power wire. Okay? So for creating these connectors, this is a 10 amp SBT2 wire, and I'm just going to take this off so I could show you how it works. Can you see the connector very well? So there's 2 little fang teeth in there, and I'm going to cut the end of this wire so that we're starting fresh. And you want sharp clippers, because if you have clippers that do not cut sharp, you'll have like a little fray or something, and if it doesn't cut cleanly and there's like furry wire hanging out, then that will cause problems, and you'll put a connector in and have your whole install, and it keeps tripping a breaker, and you don't know why, and it's super frustrating. So always have sharp clippers. Boom. So there's 2 little fangs sticking up on opposite sides. You shove this sucker down into that hole, and this could be a this is a SBT1 plug, and so it's supposed to be going on a thinner wire. So here's an SBT1 wire that it's meant for, So these plugs will say on the bottom if it's SBT1 or SBT2, and this one says SBT1. For the company, we try to keep all of our SBT1 items black, and we can see that this is actually black wire for this SBT1 socket wire, and we keep all the SBT2 stuff green. So I'm not sure how we ended up with the SBT1 green plugs, but we do. So you stick that in the hole and you shove your connectors down in there. It's an extra little step, but if you don't ensure that you have great contact, over time you'll end up having plugs that don't work well, and then you have to go troubleshoot them later. So do the little extra step of shoving the wire onto the prongs, and bada bing, you have the male installed. So for this, same method, put the female on the end of the power wire. So, and then the other end of your power wire would have the male. So the male is going towards the power. So don't mix those up, because like for instance, a common mistake would be to have two males. So, and if a male is on this side and on this side, when you plug this side into the actual power, this, when you touch it, will shock you. So if you're into that, awesome. So here's a little extra tip for you. You don't have to just stick to the ends of the wire. So what you could do, like if you had this installed on a gutter and you wanted a power wire to come down right here, instead of going all the way to the end, and let's say that this is like 50 bulbs away, you could actually just stick a male plug right in the middle of this run. The way you do that is you take your sharp snippers and you just break out the back. A lot of the female already has like a little spot that it makes it easier, and I guess it's not as recommended to do this with males, but you can, so that you could get the access right in the middle. So you just bust out the back and you lay that wire across there and go through the same procedures. You shove it down in there really good, and you got to make sure you're going to slide the cap on the right direction, because if you start this open-ended section of the cap on the side where you bust it out, it gets a little hairy. It doesn't want to do that. So you want to start on the side that you're supposed to, and just slide it in. A lot of guys will take their snippers and just like use the leverage in there to smash that lid across, because sometimes, especially when it's cold, there's a lot of resistance and it's annoying. So that is the deal with the power cable. So once you have the power rules in your head, you know, like, don't put more than 135 bulbs on one SBT2 run for incandescent. As long as you follow those rules, you could do anything with these connectors. You could put females in the middle of lines and have other lines connect into it, as long as the total bulb count doesn't exceed those rules. So I hope that was helpful. Tune in next time. Until then, I'll see you later.